Leslie,
Good afternoon, everybody.
Afternoon, evening. It's getting darker earlier, so I guess that means we have to start saying good evening.
You do.
Yeah. Hey. How are things going with Thermoshade, Diana?
Excellent, excellent. Lots of good things. I joined the Attachments Rating Council, which is the Department of Energy group.
Oh,
And so that'll be really interesting. So a lot of testing opportunities and projects. So
well,
thanks for asking. Yeah.
Yeah, that's always probably one of the things that I try to encourage entrepreneurs is that there's a whole body of stuff out there that, you know, as you well know, that there's a lot of networks to go plug into. Like if you're talking hydrogen, I know what their resources board is doing. There's groups like the Western States Hydrogen Alliance, and California Fuel Cell Partnership has been working on fuel cells with hydrogen since I first saw that sign.
So excited about hydrogen. I'm just like, no, less
Welcome
electric, more. Let's talk about hydrogen more, please. So this is going to be good.
Did
All
anybody attend the EPIC? EPIC is EPIC, and it was a long workshop today. I only attended, maybe 1 hour out of at least 4. I was just wondering if anybody else. They had the CEC commissioner speaking and the PUC commissioner speaking, and then a variety of workshops on different topics, including transportation.
I did see it. I wasn't able to join.
I couldn't make it to this EPIC forum. That's one thing with it going virtual. EPIC forums used to be, it felt like once a year.
Right.
But after they did that first one last year, I feel like they've been doing them on a much more consistent basis, which is really good.
That's right.
I'm going to shoot Gary a text, and then we're going to start moving on with the event.
I still don't see Leslie though, Thomas.
Oh, okay, you're right. I thought I saw her
Popped
disappear.
on and then she popped off. But
Yeah.
she may have had a struggle with getting on.
While we're getting started, did anybody attend the other meeting that conflicted with EPIC, which I missed? It was sponsored by the CalISO, and it was a deep dive into the challenges of energy storage.
I started that, but I did not. I've had to work for most of the day, so
Okay.
they do.
Okay.
I think they do have them recorded because I've watched some of the CalISO ones where they've talked about storage and grid balancing. But I'll be honest, like a lot of the stuff that they tend to get into, I feel like a lot of it is just that combination of regulatory and grid balancing knowledge that I need to read a book while I watch it to catch.
A little weedy.
Yeah, which is great. And, we've put on our, virtual power plant DER talks, and they get really in depth. But you can dive even deeper.
Absolutely.
I know Gary will be with us shortly. Jennifer and Roxy, do either of you have a good number for
I was just gonna say, I wonder if I can text her.
Goodyear?
Oh, I
Yeah.
can text her, yes.
Yeah.
Oh, Leslie said, are you in? Zoom is freezing up on my computer. She did text me.
Ah,
No, look, but she just texted me a minute ago. I am in.
She's like me. She may have to reboot her computer or close a bunch of crud. I don't reboot.
Always at
At
the
least
worst
every
time.
2 days, I have problems.
That was the start of the pandemic for me, and then I decided I'm going to build a computer literally to deal with this. All right, well, I'm going to go ahead and start on some things, and just so that we can get going with it. We are people starting to watch online, so that is kind of surprising. Okay.
YouTube?
Yep, YouTube. All right. Well, welcome everyone to our CleanTech meetup tonight. I'm Thomas Hall, Executive Director of CleanStart. If you want to, thank you for attending here. And if you want to go ahead and follow along with these slides, I'm going to drop these slides into the chat for you. There's more people joining. Also, if you want to share the live YouTube stream, I'm going to go ahead and put that in the chat for you there too. So you can share this and follow along with me. Now, if you have a clean tech idea and you want to connect with CleanStart, please do. CleanStart's been around for 16 years, and we are here to turn Sacramento into a clean tech hub. And we like to work with entrepreneurs and connect them to the networks that they need. If you have an idea, feel free to reach out to me. Here's my Calendly, so you can go and have coffee with me, and we can figure out the best ways to support you. Additionally, I want to thank our sponsors of this meetup, Sac State, SMUD, Weintraub Tobin, and Blue Tech Valley. This is also sponsored and brought to you by other parts of Sac State. So if you want to connect with Sac State, I really suggest you reach out to the College of Engineering and Computer Science. The Associate Deans, Jawa and Shafizada, are great supporters of CleanStart and the entrepreneurial ecosystem. And Cameron Law is a huge supporter of entrepreneurs because he's at the Carlson Center for Entrepreneurship. They put on some great classes there. Connect with them and start a business. I also want to thank everyone here for their support. All the support that you guys give us for these meetups, it doesn't just mean a lot to us monetarily. It also helps validate us to know that we're on the right path. If you really like what we're doing and you want to continue supporting us and help us continue to put these on, feel free to support us by donating at our PayPal page or subscribing. Now, how tonight's going to go? We're going to have some quick announcements. Then I'm going to have the guests do some presentations, and then we're going to have a panel discussion. The quick announcements are: make sure that you check out Global Entrepreneurship Week. Global Entrepreneurship Week is at Sac State, and they partner with all sorts of organizations around Sacramento to connect entrepreneurship to students on the college campus. We're working with them for our November 12th Global Entrepreneurship Week, Building the Future and Moving from an Engineer to an Entrepreneur. It's going to be a great discussion with Terzo Power, Eco Alpha, and more. Also, save the date, November 18th, we're having our spotlight pitches again. All right, and if you've missed some of our previous ones, make sure you go to our YouTube, and I'm going to share our YouTube with you here, because they are all full of good information. So follow us on YouTube, LinkedIn, and Twitter to make sure you stay up to date on these things. All right. And with that, I'm Thomas Hall, Executive Director of CleanStart. I'd like to welcome you to our discussion on alternative fuels. There's probably going to be a heavy focus today on hydrogen. And hydrogen is a great example of an alternative fuel because there's just so much you can do with it. You can use it for storage. You can use it for transportation, and you can use it for a lot of hard to abate sectors in the industrial area. So if you have questions, put them into the chat, and we'll make sure that we try to answer them at the end of this, or during the panel discussion. Now, I would like to welcome Jennifer Hamilton, Roxana Bekemohammadi, and Leslie Goodbody. I believe she made it in here, right? Oh, there she is. Okay, good. I'm going to make you a co-host, so when you're up, you can share your slides. These are, as I've been kind of telling people, if you're trying to build a company or a technology, there's all these networks to plug into. And if you're trying to figure out, like, hey, I've got an innovative use of hydrogen or an innovative way to make it, transport it, store it, you want to make sure that you connect with the strong ecosystem that's there. And that's like the California Fuel Cell Partnership, the Western States Hydrogen Alliance, and you definitely have to know what's happening at CARB because they're funding a lot of these projects. First up, I would like to welcome Jennifer. Jennifer has been with the California Fuel Cell Partnership since 2006. She actively participates with and supports the development of national and international safety codes and standards. She also leads the hydrogen education and outreach to the emergency response and permitting official communities. Jennifer, along with the rest of the California Fuel Cell Partnership, works with their members to grow the hydrogen market in California and beyond. So I'm going to go ahead and spotlight you, Jennifer, and I will have your slides up in just a second.
Great, thank you. I'm not sure what spotlighting means, but okay,
Oh.
I'll take it.
You're in it.
All right.
Everything look good?
Okay, great.
All right.
Thanks so much, Thomas, for having me at this event tonight and for the kind introduction. I would like to briefly talk to you about some resources around the retail hydrogen fueling stations. So we'll go ahead and go to the next slide, please. At our headquarter office in West Sacramento, which Thomas and I were chatting about, you've probably seen the sign, that's 50 or 80, whichever, I think, where they kind of come together behind our back lot there. We had a fueling station for 13 years, and that provided a great place for our members to do a lot of work to get to where we are today. And that work is certainly not done. It's still being expanded upon as we move into heavy duty, but for light duty refueling, there was a lot of the basis for it was done at our station. So next slide. Some of the big ones include the fueling protocol. So there is a standardized fueling protocol for light duty vehicle refueling. And as I mentioned, the heavy duty is being worked on as we speak. Also, there's a communication protocol for communicating between the vehicle and the station. There's also work being done on that around heavy duty. Metrology. So we do have Division of Measurement Standards in California does come and put the seal on the dispenser and verify that the consumer is getting what they're paying for. But some of that work was done at our station, and also fuel quality. There are fuel quality specs that need to be followed for putting hydrogen into these vehicles and using them in the fuel cell. So those are some of the big things that our station was able to provide our members with a resource to use to develop some of that stuff. Next slide. So back in those early 2000s, we had stations that were demonstrations. They were behind a fence, kind of like the one you just saw, one we had for very small fleets. And as we moved out into the teens, we wanted to develop these clusters of stations to start getting, fueling for the customer and developing that market. And now we are in the early market for hydrogen vehicles and refueling. And that's a shot of our station map that you can find on our website. So you see there's a lot more bubbles there. And if you go to the next slide, we are moving even further. So AB8 is funding that is funding many of the stations that are on the ground now, if not all. But we also have a low carbon fuel standard that is through the HRI credits that's funding some stations. And we have some goals for more stations, more vehicles that we are working diligently to meet. And you'll notice that in that 2030 vision, it's not just light duty, but medium and heavy duty as well. So as I said, we're working on that stuff. So the resources I wanted to mention tonight around this are on the next slide, and that there's two that specifically I want to highlight. One is something that our members at the partnership developed. We refer to as the Station Buyer's Guide. It's a couple-page document. It's got some information and important considerations for folks who are interested in acquiring a station, building a station, owning, operating, and so forth. It is concentrated on light duty vehicle refueling at this time. There's no heavy duty there yet. It does include references and links to other resources, including the other one on this page. And there is a table in there with some key codes and standards, and it's certainly not an exhaustive list because that would be much too long, but it's kind of some of the high level, big, important ones that then take you down the path for the more specific ones. And one of those resources or links is to the Permitting Guidebook from the Governor's Office of Business and Economic Development. That was recently updated in late 2020. It's meant to also assist project developers like the Station Buyer's Guide, but also local authorities who might be permitting these stations in their jurisdiction. It provides quite a bit of background and insights into the history and kind of some background on the technology and the stations and then looking forward. It is divided into 6 parts, but the part 3 is what concentrates on station development itself and then is subdivided into the various kind of phases of station development. So a couple of, I think, pretty good resources for people interested in that, and certainly a good start. I think that's come just about to the end. I have the next slide is something that I like to highlight because I really think that hydrogen is one of the things that's really going to bring a better future for my kids and your kids or grandkids or whomever, or for us. So with that, I will leave you with our member slide, I think, just so you can get an idea of who we are, who our members are, and thank you again for your time.
All right, thank you very much. Excellent. And now we're going to move on to our next panelist. All right. So I'd like to welcome Roxana Bekemohammadi. I'm Executive Director of the Western States Hydrogen Alliance. She came highly recommended, and I'm really looking forward to hearing about what they're working on. You're muted.
Thank you so much, Thomas, for putting this together and putting us together. I actually adore Jennifer and Leslie here, and actually Yachun as well. So this is an exciting afternoon for me. Thank you for highlighting hydrogen and fuel cells. It's a critical feature of essentially the clean energy and transportation landscape. And I would love to talk a bit more about the Western States Hydrogen Alliance and did you want me to put up my slides or?
Sure.
Okay. Let's share screen. You also have a copy of them.
Okay, I hadn't seen it yet. I'm sorry.
No worries. Okay, so here we go. There we go. So I'll say my last name just for fun. It's Bekemohammadi. The second E is silent. It's there to trick you, but really there's just too many letters in it. I'm the Executive Director of the Western States Hydrogen Alliance. We actually have, we just turned 1. We look so young. And we are so excited to do the work that we're doing. Really, we've been taking actually a lot of the learnings from California and taking it into the Western states. Really feel like we're acting like pioneers here, taking the information about basically what's going on and what should be done for hydrogen into these other states. I will say that we do have an emphasis really just on commercial and industrial applications. So we're looking at, deploying hydrogen and fuel cells on a large scale in commercial applications. So be it commercial fleets, be it busing, trucking, vessels and whatnot, but we'll get a little bit more into it as we go through my presentation. So our core principles is that we really are basically serving as a thought leader on the mass deployment of fuel cells and hydrogen across the Western states. We're really focused on doing that thought leadership with policymakers and showing them that hydrogen and fuel cells are part of essentially, yes, the clean transportation energy sectors, but really it is a zero emission technology. It is part of electrification. And, as much as people have a hard time understanding this, unfortunately, petroleum is quite the magical fuel, and to replace it in its entire capacity in every respect, it is very difficult. And so we're really going to have to embrace multiple fuels and multiple strategies to really move away from a fossil economy. We're also very focused on being pragmatic, you know, looking for the economic synergies that we can promote, really, you know, ensuring that there can actually be regional growth, and maybe some economic strategies that we can deploy in order to get these right now high cost equipment to market in large scales, and into the hands of those that are in the commercial or industrial sectors, which is pretty much a hard sales point, pretty much, because at the end of the day, they have to make sure that, you know, they're making decisions for economic reasons, right? They have margins that they need to maintain. You know, they're not making decisions for ideological reasons. Like we might see with some folks that, you know, might pick specific electronics or passenger vehicles, or et cetera. So most don't know, but I am a nerd. I have a background in engineering, and I've actually taken that background and I've used it in policy. So I think that I've really been eager to really ensure that we have well-rounded policy. And so, you know, actually one of the first faces I saw when I got to the Air Resources Board was Leslie Goodbody. So excited to speak with her here. And then I did some project management after that, but really focused on policy advocacy over the last 5 years, almost 5 years. These are some of our members. We have some more members that we need to add on, but you know, we're really happy to be supported by our current members and hopefully future members. So the areas that we're focusing on, as I mentioned, is busing. So to the left, the top left, you see a fuel cell bus. We see, you know, we're not at 100 yet, but we're seeing many tens of fuel cell buses that have been deployed. We're really excited to see more of that technology on the ground. To the top right, you'll see a Hyundai fuel cell truck. We're very much eager to support the deployment of these fuel cell trucks across the Western states and beyond. We're, you know, making strides in different state houses to ensure that they have the right incentives and additional types of support. And that can be very broad when we're talking about policy support to ensure that we can look at basically decarbonizing freight. To the bottom left, you see a fuel cell ferry that's actually going to be on our water on our California coast soon, hopefully before the end of the year. The group that put that together is Golden Gate Zero Emission Marine. They're also known as Zero Emission Industries now. And to the bottom right is kind of a cool feature, which is actually that's the Mars rover. And you know, it has only 7 instruments on board. 1 out of the 7 actually is one of our members' technology, which is Oxide. They have a solid oxide electrolyzer, and it's super cool. An electrolyzer is basically a fuel cell in reverse. It is taking CO2, so carbon dioxide from the atmosphere in Mars, and turning it into oxygen. And that is an experiment they're doing to see if they can generate oxygen for Mars. I wonder for what purposes. But really what I do want to emphasize is that hydrogen has been with us and in our civilization for at least over a century. We just don't usually see it. Because it's been in the commercial and industrial sectors. I mean, it is hydrogen that took us to the moon. Hydrogen is what's in our fertilizer that helps us grow our food. It's, you know, the most abundant element in the universe. Truly, you know, we really should be kind of putting hydrogen more on a pedestal, I would say, but maybe I'm slightly biased. So, you know, again, what's most important to us is really the end user's consideration, right? Because if they don't have a positive experience, there's really, I mean, really the technology is just, it's not going to be deployed. It's not going to be successful. It's not going to have a future. So, you know, how much does hydrogen cost is a big feature, especially in these heavy duty applications where really the capital cost associated with equipment is nothing compared to the operational cost of operating it over decades, potentially. One of those fuel cell ferries alone consumes almost a metric ton of hydrogen a week. So, I mean, these are massive amounts of hydrogen that would be consumed. So that's where the cost of hydrogen is really important. So for us, what we strive for is achieving diesel parity, bunker fuel parity, jet fuel parity. That's what we're going for. There's a lot of back and forth about how clean is the fuel. And I like to remind folks, especially outside of California, that your grid is pretty much probably either more than half, powered by coal and natural gas. So, your electricity is not as clean as you think. It's good to do a wells to wheel kind of analysis when you're looking at the vehicles that you're deploying. And also right now we're very much focused on, again, diesel parity. So, at the end of the day, every fuel cell vehicle has zero emissions. The only emissions you're getting is water vapor. And another thing that, we like to explain to legislators in the Western states is that, not every state has plenty of water, but we all have biogas, and, hydrogen can come from biogas. And so that is definitely a renewable pathway for hydrogen as well. And then the logistical hurdle, which is how do I receive the fuel, that becomes extremely critical in heavy duty applications, because we're really looking at these massive ecosystems. So we're looking at consumption at seaports, airports, distribution centers, industrial parks. So it can become a little bit of a hurdle, essentially, once you're looking at truck deliveries in the tens a day. So there will be alternatives that will be necessary, potentially pipelines that will be absolutely critical for a seamless operation for a zero emission commercial setting. And I'm always available. You can totally reach me at my email, my phone number, on LinkedIn. Feel free to reach me at any point. And that's it on my end. Thank you.
Thank you very
Right.
much.
Thank you very much. And with that, everything moved around, sorry. All right, All right, next I'd like to welcome Leslie Goodbody, Air Resources Board Engineer. Leslie is currently has been entrusted with many high-level, heavy-duty fuel cell electric vehicle demo and pilot projects, and has over 15 years of experience in the fuel cell electric vehicle field. She has recently been tasked with supporting CARB's zero emissions vehicle infrastructure work and collaborates with various state and federal agencies on advancing fuel cell electric vehicle technologies and hydrogen station development. So I've highlighted you, and I'm going to put your slides right up, and when you see them, you can go ahead and start.
Okay, thanks, Thomas, so much. And I have to say, it's a real pleasure to be here in such good companies. I have, like I say, 15 years, which means, yeah, I'm pretty sure Jennifer's been in this as long as I have, and I have known her that long. And yeah, Roxy's my girl. I so love and appreciate the work she's doing right now, and I'm so proud. So as you mentioned, I am working in the zero emission space in general for the last 15 years, but of late I have been working with incentive programs, and that's been super exciting because we are funding advanced technologies in the heavy. I'm working in the heavy duty realm, so I've got to see transit buses go from, maybe 1.4 million each or 2 million each down to just shy of 1 million each, which is actually a really big step, but those costs are trending down as production is going up. So I think the the hydrogen story, which we should all be echoing, is scale. It's once we get to a large scale, this is going to be a real dominant fuel in the zero emission space because of its versatility. But first, I'm going to talk about, let's go to the next slide, why we're here, why we do this. Transportation is the largest source of greenhouse gas emissions and tailpipe emissions. And tailpipe emissions are the largest source of NOx. This causes serious health problems, air quality problems throughout the state of California. And that's the reason we've set some pretty aggressive greenhouse gas goals to mitigate the impacts of climate change, as well as, our very strong need to reduce those criteria emissions, diesel particulates, and NOx, especially in those areas that are most adversely impacted by poor air quality. And the health impacts are fairly severe in those areas along the freight corridors throughout the Central Valley, in numerous locations. So this is like our top priority these days. That's probably why over a year ago, Governor Newsom signed the executive order that required all new cars and light duty trucks sold in California to be ZEV by 2035. And then a goal of transitioning all drayage trucks and off-road equipment to zero emission by 2035. And the goal of transitioning all other medium and heavy duty vehicle fleets to zero emission wherever feasible by 2045. So meeting these goals is going to require reductions across all of the sectors. So the focus on transportation makes a lot of sense, considering that it makes up over half the GHG emissions. When you include the upstream emissions associated with the fuel. And so the clean combustion technologies are an important near-term solution. For CARB, zero emission really is the end goal. And we do see a path forward here. I think as Roxy was teeing up the different ways that you can produce hydrogen, this slide kind of gives a little bit of an illustration. And I'd like to say these are your conventional ways of producing renewable hydrogen. So when I say hydrogen, most of the time I'm going to be really talking about renewable, because that really is our end goal. So, we touch on biomass resources. Right now, probably producing, say, renewable natural gas from biogas, turning biogas from dairy digesters or manure into renewable natural gas. That is the way probably a lot of the renewable gas is produced today, injected into the pipeline. So we've got a really vast pipeline network, and then is used to fill cars, natural gas cars. That's a combustion technology. It certainly can be superior over other combustion, but still it's not part of our end game. So the beauty of that pathway is that you can then take that renewable natural gas and reform it and produce hydrogen from that, and then use that hydrogen for a vehicle fuel or for other sources. But really a bigger focus is the use of renewable electricity. And the focus a lot lately has been with renewable electricity is how do we capture that electricity so that we can use it when we need it? Oftentimes the wind might not be blowing when we need it to. The sun's going to shine when it does, but there's oftentimes the demand isn't necessarily matching up with supply. So much focus these days is on how do we capture and store that energy so that we can then charge our electric cars or produce hydrogen. And so we've been looking at, the utility's been looking a lot at using batteries for near term, short duration energy storage for about a four hour period. I think that's what the the useful batteries are best at storing energy for short periods of time, and it's perfect for capturing that excess solar in the middle of the day and then using it later in the evening when everybody comes home and turns on their appliances and causes some real peaks. Hydrogen is a really great resource for capturing those stranded renewable electricity, but it can hold it for a longer time. So with hydrogen, you're only limited by the amount of storage you have. So this kind of, and then hydrogen again, like Arut says, it can be compressed into tanks, taken to a station, used to fill cars, or liquefied, taken to a station and used to fill transit buses. So there's a lot of pathways to get to hydrogen and then to get that hydrogen to where it's needed. So this next slide kind of talks about all the vast uses of hydrogen. It's this is a great resource provided by, you go to the next slide, Thomas. This is from the US Department of Energy's Hydrogen and Fuel Cell Technology Office through their H2 at Scale effort. And what it does is it emphasizes that renewable hydrogen can be used not only for transportation and grid resiliency, but it's also has value in in decarbonizing a lot of industrial sectors, like various chemical and industrial processes, ammonia and fertilizer production, metals production, conventional fuels. So with the key to the DOE's H2 at Scale initiative, which now they're actually calling Mission Innovation, is to work towards building up the production of green or renewable hydrogen or low carbon intensity hydrogen to bring up that production up to a place where you can drop the cost down. And they've set a really ambitious target of $1 per 1 kilogram in 10 years. It's quite quite ambitious, but I think that's kind of what goals should be. And one of the things I'd like to mention is electrolytic hydrogen. You know, people will say, well, why don't you just put electricity to charge the cars? Well, there's a whole storage and transmission thing, and electricity is absolutely used to charge batteries in cars. But it's also a really great way to produce hydrogen to capture vast amounts of stranded renewable electricity that would otherwise be curtailed. And that renewable electricity, if it's purchased from a source where you can get it pretty cheap, that will really bring the price of hydrogen down tremendously. I would say for hydrogen that's produced from electricity, the main cost driver and the main cost factor with that is the cost of electricity. So if so if we can get that down, you know, either through and honestly, folks are working in that direction. So I'm going to go to the next slide and just sort of, you know, talk about like what is needed for a sustainable hydrogen future. So these first 3 bullets, they sort of talk about the vehicle owner perspective. First, they're going to need comparable costs. You know, we need diesel parity for trucks. But what we know, and what I said before, is cost of hydrogen will come down with scale. It'll come down with access to cheap and abundant renewable resources. It will come down with larger scale production facilities, more production facilities, but also that hydrogen cost will come down if the carbon intensity is super low, which means hydrogen made from electricity is going to have a real benefit. And that's because we have this program in the state of California called Low Carbon Fuel Standard. And basically, the long story short is the lower the carbon intensity of your renewable fuel, your replacement fuel compared to its diesel counterpart, the more credits you can earn and the more valuable your fuel is on the market, because that will help drive the overall cost down, especially when we have a steady supply and a competitive supply. So a sustainable hydrogen future is going to rely on a lot of in-state production and a lot of competition within that in-state production, so that the stations, when they need the fuel, they're able to get it, and maybe they're able to do some bidding. You know, maybe they're able to compel the producers to be a little bit more competitive. And then the third would be that robust fueling infrastructure network. This comes with duplication and standardization. And what we've seen with the light duty stations that have built out that Jennifer showed you the map of, the cost of that network really has come down quite a lot. And at the same time, the price, the cost of the stations to build the stations, to get them certified is coming down just through duplication. But at the same time, those stations have greater capacity. So for less money, they're filling more cars. So that's been a really exciting development that you can read all about in the 88 report that you can find on Jennifer's, on the California Fuel Cell Partnership website, as well as ours. And then let's see, the fourth bullet here addresses climate protection. And that will really come with a strong and consistent incentives like the low carbon fuel standard that's going to require, you know, again, what low carbon fuels, super low carbon fuels are going to get a premium. And that will be what people are going to be producing, wanting to buy, because that's what's going to drive the market. And then domestic production, of course. Like I mentioned before, if we have consistent incentives and encourage in-state production, we'll be meeting the demand. And right now the demand is greater than the supply in the state. And so I think the market is ripe. And that would be how I would close it. I think the opportunities here in California are fantastic. So we're hoping that everybody else sees it that way. Thank you.
Well, that's
Excellent.
terrific, Leslie. Thank you very much.
I'm going to go ahead and call back, I guess, all of our guests and highlight all of you. Add spotlight. Add spotlight. And then I'm going to grab Gary, who's going to lead the panel. And one thing I wanted to also highlight is a month or so ago, we talked about the low carbon fuel standards. And something that really surprised me was the amount of reductions that have come from alternative fuels and versus electrification. If you had asked me before that, I would have said all the advances were coming from electrification, or the majority of it was, and that's just simply not the case, and it's not even close. So I'd encourage you to check that out, since Leslie highlighted it as one of the paths to decarbonization. And with that, I'm going to let Gary go ahead and take over and welcome everyone back for the panel discussion. We will get to the questions that we've seen in the chat. Gary, we'll call on you. So we're going to have a first quick discussion. All right.
Well, thanks so much, Thomas. And just following on from that last discussion we had with Dan Mazzoni at UC Davis, there is a market for low carbon fuel credits in excess of the target reduction level. And I think we were all amazed at the price that those credits are going for. It's really quite a financial incentive to move towards the alternate fuels, and one way to begin to level up the prices of the alternatives against the conventional fuel. So we have that as a video and as a blog, so take a look at that. Turning back to the presentations, they're terrific. I mean, there's a lot of things here that probably many of us don't keep on top of, but let me explore a little bit more. Jennifer, on the station map and the goals, where are we now on the number of stations that are operational? I know there's some under construction, there's some are planned, but where are we on the operational number?
Yeah, it's a good question. And on the Fuel Cell Partnership page, we do have a by the numbers page where you can see the numbers of stations, the ones that are in various phases of development, numbers of vehicles, including buses. And you put me on the spot. I think we're at around 50 stations that are available to customers now, with another 60 or so that are in some phase of development or have been funded. Something that was really wonderful about the last solicitation that the Energy Commission put out, which they, AB8, CARB's AB8 provides the funding, and the Energy Commission puts out the solicitations for that, is that they did it in such a way where the station developers could put in their bids for much bigger groups of stations. So it wasn't 2, 3, 4, 5 stations. It was 10, 15, 20 over the coming 4 or 5 years. And so that's really something that's helped with driving the cost down that Leslie was talking about, you know, those economies of scale.
Right.
And so that was something really great. So what we've seen is there's a lot of stations that are funded, and then we're also seeing those privately funded stations that are coming from the HRI credits through the LCFS too.
Well, the other theme that stretched over all three of our speakers today is price. And it's something that we watch like a hawk, because that's where the differences are made. You think you're a nerd, I'm a nerd, because I drive by the refueling station in West Sacramento frequently and just find out what the price is at the pump there. If you Google the wholesale price of natural gas, depending on where you are in the country, it's actually pretty modest. It's like $2 or $3 a kilogram, and a kilogram is about the equivalent energy of a gallon of gasoline. The pump in West Sacramento has been at $11, $12 per kilogram, which says, wow, there's a lot of cost between making the fuel and then transporting it, distributing it, and dispensing it. Where are we in trying to really burrow in on those costs of distribution and dispensing to cut the pump price?
Yeah, so
Jennifer first.
oh, sorry, I just assumed you were asking me. But I think both my colleagues would agree that that's really something that the heavy duty market can help with, because of, again, those economies of scale and the large use. What we're also seeing is more production coming online. There's a lot of projects that are coming to fruition soon, or will be in the coming few years, that will add, you know, the hydrogen to the market, and from a lot of different sources. So I think that's absolutely something that's on everybody's mind, is the cost to the consumer at the pump. And again, DOE has targets for industry to meet, and so everyone's been working towards that. And I think we're at a point now where we're going to really start seeing some differences fairly soon. So Leslie or Roxana, you guys chime in, please.
Yeah. Anybody seeing some market changes in the distribution and dispensing costs? Because those seem to add quite a few bucks.
So I'll chime in on the retail side versus, what people are seeing at the pump. There's a lot of energy and effort that goes into taking hydrogen and compressing it to 700 bar. And I think there will be somewhat of a premium associated with really packing hydrogen into a light duty vehicle tank. If we take the whole retail piece out of it, what I'm seeing for transit is $8 a kilogram, but that's what a transit station is paying to fill up their liquid storage. Then there's some energy, but it doesn't really amount to much of a premium on top of that to vaporize it, turn it into gas, and compress it at 350 bar. That's 5,000 PSI, where 700 bar is 10,000 PSI. So what they're seeing in a non-retail setting is a lot less. But as Jennifer said, this is simply there's those factors that all need to come together. There's scale, competition, low carbon, so you can really get the price premium down because of low carbon fuel standard. We will see, and we're seeing announcements and everything about people seeing the market and the value of having a hydrogen supply market in the state of California, or serving the state of California, such that, so you understand low carbon fuel standard, such that you can get your fuel registered into the system and its carbon intensity. And the players know this, and they're doing it. So I think it's just a matter of time. And the Energy Commission is our sister agency, and they are dedicating funding that they're able to get towards hydrogen production, renewable hydrogen production in state. So I think the future is not that far away, where we're going to see a lot more competition for clean, renewable, cheap hydrogen in the market. And I think just because when you have a situation where demand exceeds supply, it seems like a no-brainer. So the prices that people are paying at the pump sort of are reflective of what the current market is, and maybe a few players that sort of dominate the market. And we just need competition.
But remember that light duty customers also, when they lease or buy the vehicles, do get a fueling card from the vehicle manufacturer to help offset that. You know,
Right.
we understand that's.
So tell us about that. So what's on the fueling card? Is that some way of getting credits at the pump or?
Money. It's about 3 years worth of fuel. And so, you know, like I leased a Mirai, and that was 3 years. And so my fuel card had, you know, based on your mileage of your lease, right? And kind of average driving, you'd have enough for about 3 years of fuel. And so that's an incentive, you know, for the consumer, understanding, and of course, everybody knowing that the price for the consumer has to come down at the pump. But, you know, that being said, these vehicles are very efficient in how they use the fuel. So the price per unit, per kilogram, might still look like a little more, but if you average it out on a per mile basis, could be equivalent with gasoline. And we're seeing gasoline at $4+ a gallon now. And so really, at some stations, it's not that far off, you know, so it's kind of relative to for people as to what gasoline's costing, because everybody compares it to.
Yeah, well, certainly gasoline has been going up, so
Yeah.
That's helped balance the two prices.
Hey, Jennifer, I just did the math. We're at parity.
Are we?
Yeah, I mean, if you're
Yeah.
paying $11 a kilogram at the West Sacramento station, and I think the market, I mean, I think the EER on that is like you can get 2.5 times the mileage in a fuel cell vehicle. Well, that comes down to $4.40 a gallon.
Mm.
So
There
just
you
thought
are.
I'd share that.
Yeah.
I'm a nerd too.
Roxana, let me turn to you, because you're focusing a lot on the commercial industrial market and the heavy duty applications. Of course, a lot of companies that make gas turbines don't want to see their markets disappear. So they're adapting their engines to run on either pure hydrogen or blends with natural gas, whether conventional or renewable. What's the view from your organization in terms of whether the buses have a gas turbine in it turning a generator and they're still basically electric buses versus a fuel cell?
Well, you know, it's interesting. Hydrogen combustion has been coming up a bit recently, again. So, you know, you can have massive hydrogen combustion as you were talking about, like a stationary gas turbine producing power. You can also have hydrogen combustion in an engine, in a transportation application. You know, I don't know if we have a position. We have not been forced to take a position on that yet. You know, I think on the utility scale, that's interesting. You know, I would have to say, I don't know if the footprints are yet equivalent, a stationary fuel cell compared to let's say a hydrogen combustion or a turbine engine. But on the transportation sector, I mean, in that respect, you're still going to have NOx emissions. And that will also influence ozone creation. And, you know, the question is, do we want zero emission tailpipe emissions? And so, you know, I would have to say that we probably want to focus on fuel cells in those applications if possible, but you know, we are a bit pragmatic, and we do understand that there is ways of transitioning, but you know, I don't know how promising that is, at least on the transportation side.
Hey, can I chime in on that one?
Yeah,
I do
please.
think we should think about, no, I think, and then also combustion versus conversion. I mean, basically what's happening in a fuel cell or battery electric, a fuel cell car is taking the hydrogen and turning it into electricity and running an electric motor, which is much more efficient than an internal combustion engine, than running pistons. So if you're burning hydrogen versus using it in a fuel cell, you're going to get much more efficiency. That is really the benefit of hydrogen. It kind of speaks to some other questions that have come up of like, well, why don't we use this? Isn't it better for a CO2 footprint to use renewable natural gas and burn it in a natural gas vehicle versus a combustion engine versus converting that to hydrogen? Well, natural gas engines are less efficient than diesel. And hydrogen fuel cell, hydrogen run in a fuel cell could be, a lot more, maybe twice as efficient in a heavy duty vehicle than burning natural gas in it. So it really, you have to think about the whole picture. That's the point we should really be taking home, is fuel efficiency when you're talking about how much the energy content of the fuel is versus how efficient it is in the application.
Yeah.
It's a whole picture.
There are applications like farming equipment, right? That the margins are super low. They turn over their equipment every half a century. Would I rather have hydrogen combustion in a scenario like that? Yeah, I would take that over for diesel. But when we're talking about buses, when we already have commercial applications, Leslie's spot on. We have the efficiencies, the margins aren't, they're doable. In a scenario like that, I really do think like every application, it's worth really looking at the economics and the turnover of equipment and what the typical usage looks like.
Well, either for you, Roxana, or Leslie, there's also a lot of discussion on blends. Let's blend 25% hydrogen into the methane stream and use that as a transition strategy and bring down the carbon intensity of what we already have, possibly use that in CNG engines that are already out there. Does that have legs? Does that speed the transition to lower carbon fuels, or does it just get in the way of the ultimate transition to the fuel
The
cell?
way I've been seeing, my 2 cents in on this, the way I've been seeing this discussion go is absolutely yes, it has legs in decarbonizing the natural gas supply chain. And so they have been looking at blending in the pipeline to just bring the carbon intensity of those fuels down that are, and they've been looking at how safe is it to use, what blend is safe to use, say in a home that, has a natural gas oven or something. And as well as, so, I think people have been talking at and looking at up to 20%. So there's definitely, it has legs. And one thing that speaks positively to that is that increases the production of renewable hydrogen such that it's a scale issue. The more we get into the system, it can actually use to help decarbonize or lower the carbon intensity just of the whole natural gas supply chain. So certainly DOE and others are looking at that very intensely, as are the utilities.
Yeah, there's a DOT PIMSA public forum coming up for R&D on hydrogen and pipelines. There's a whole lot of interest in blending and a lot of interest in the pipeline work, and the utilities are getting in on it and everything. But everything from how high can you go? 20% is pretty high. I think materials compatibility, development of new pipeline using existing, like all kinds of stuff. So.
Yeah, I think being resourceful is important here, right? This is amazing infrastructure that was highly expensive to put in. How can we reutilize it? So be it through blending or, through some more innovative processes like Jennifer was just kind of touching upon, which is, potentially a pipe within a pipe, which has been discussed. That's one way of utilizing the natural gas pipeline, which, just actually for this audience, where there's discussion about inserting a pipe that would be just exclusive to hydrogen and hydrogen safe within the natural gas pipeline. But also, there's some logistical matters that we need to think about, is that there's right-of-ways, right? Those utilities have right-of-way, which is really critical and very difficult to get. And so, forget about even the natural gas pipeline. I mean, the fact that they have the right of way, and maybe we can even build hydrogen exclusive pipeline, that's also critical for the transformation to just a clean energy and transportation economy. I mean, think about all of the kind of electrical wiring we would have to put up, the upgrades to the electrical infrastructure. I mean, you know, sometimes the actual logistics of just doing it gets in the way. And I think that, you know, definitely, Jennifer, you've seen this quite a bit, just in general, like even station permitting has been, I mean, the logistical burdens with just getting that done, right? And so, you know, Jennifer's been doing a lot of education over the last almost 2 decades on that issue alone. So there are those pragmatic considerations as well.
So let me take advantage of having my friend Jeff Bush in the audience. So Jeff spent a number of years with SoCalGas, probably looked at this blended pipeline thing. He's no longer with SoCalGas. But Jeff, do you have a view on the discussion we just been having?
Couple thoughts, and one was a question that I just sent over to you, but you know, the SoCalGas, as some of the speakers have mentioned, is looking at ways to maybe do a blend that would include natural gas and maybe 20% hydrogen, which might address some of the deliverability concerns and maybe help the fuel be more cost competitive in that regard. But my concern had to do with the infrastructure, the battery powered EVs, particularly when you start looking at heavy duty vehicles, are much heavier than their fossil fuel counterparts. And I'm not sure our roadways and bridges and infrastructure are capable of handling all that additional weight. So my question back to the panel is, how would heavy duty hydrogen vehicles compare weight wise to traditional vehicles, which are fossil fueled, or some of the EV battery powered vehicles that have been proposed?
I mean, I just want to put something out there. I mean, I can't give you an exact weight right now myself, but I mean, yes, you do have, you know, heavy electronic equipment on board, but I just also want to make or emphasize the fact that if you're going to throw all those batteries onto a truck, that takes a lot of footprint, essentially volume. It's volumetrically challenging. So, you know, what we like to say is that you're either, you know, in the freight sector, you're either going to be moving batteries or cargo. So regardless if what it's doing to the roadways, it's not going to be hauling anything. And so that's going to drastically, you know, raise the cost of goods. So, I mean, yeah, you're right. Absolutely. We need to care about our roadways, but maybe do you ladies have a number on weight? Okay, go
I
Leslie.
don't know about an actual number, but I know that for freight and goods movement in California, the law was passed so that for Class 8 trucks, we can actually go for zero emission, you can go up to 82,000 pound GVWR. There was a study that NREL had been working on for quite a while that sort of tried to do that exact thing of comparing battery electric versus hydrogen in terms of whether you, at what point do you weigh out versus cube out. And so this is the whole conversation. And I like to put it this way. It's right. You can get a Tesla semi to haul Fritos up and down the valley and into LA, you know, and it's going to be fine. But should Anheuser-Busch buy them to haul beer? You know, so we're going to have instances where people are going to need the weight advantage, because bottom line with the simple answer to this, I'm sure you already know this, Jeff, is like, to get more range on a hydrogen fuel cell truck, you just need more tanks. And the tank, you know, you don't have to add another fuel cell stack. You get the right size fuel cell stack, the right size battery management system and everything else. To put more miles on it, you just need another tank. For a battery electric truck, you need another battery or more. And so we're seeing a ton of sales of battery electric trucks lately, or orders for them for drayage operations and for operations that are going to be limited to like 100 miles, where they can charge in point A, load up their stuff, drop it off, hopefully charge before they go back. Maybe some of them can go up to 200 miles, but you know, beyond that, it's going to be really, really challenging. And so truck OEMs and everybody are really looking at fuel cell for the longer, more challenging routes. And that goes for buses as well.
Well, and the weight of the battery is the weight of the battery, regardless of the state of charge, right?
Yep.
So you're carrying that weight regardless of if you have a load on the truck or not, right? And so that is an advantage, I think, of hydrogen in that case. The other thing that's interesting is, you know, we have this pretty established light duty vehicle refueling protocol that has, you know, admittedly, if some limitations in terms, and that's something we're trying to work out now. But for heavy duty, we kind of have a place to kind of begin from and maybe make some innovations with that fueling that maybe, Leslie, you don't have to have another tank, because if we can get more fuel on board because we don't have to, you know, go to that higher pressure or you know, something that's kind of innovative, that could even be a bigger advantage potentially. So.
Well, thank you very much on that. Peter Mackin has made a couple comments and asked a couple questions here about using internal combustion engines versus fuel cells. Of course, a combustion turbine is an internal combustion engine as well. But Peter, you've made the point that if you're talking about a stationary system and a combined cycle power plant, they're 60% efficient, or the latest ones from GE and ABB and others are 65% efficient. I'm just not sure that we're going to be burning hydrogen in what's essentially a baseload power plant. That's a big quantity of hydrogen. But why don't you explore the question more and tell us what you're thinking, Peter?
Sure. Can you hear me?
Yes.
Okay. Yeah. So actually, what I'm thinking is it's not hydrogen itself. You know, in other words, I have no problem with hydrogen from electrolysis. I think that's for heavy duty trucks, for trains, boats, maybe airplanes. I don't know how heavy it's going to be, but you know, other you know, stationary applications for electricity generation after, you know, long-term storage and then generating electricity. That I'm perfectly okay with. My concern is more if you're starting with biomethane. In other words, you're even though the biomethane is supposedly carbon-free, wouldn't you be better off burning that methane in a power plant rather than turning it into hydrogen? And I quoted a paper that was, I think, Haworth and Jacobson or something, where they basically said that blue hydrogen is not blue, it's black. it's worse than just taking the fuel and burning it directly, burning it in a water heater, burning it in a wall furnace. It's terribly inefficient, at least from a CO2 emissions standpoint. So that's where my question is coming from, is do we even want to pursue that interim step, or should we just go directly to the electrolysis of hydrogen from water?
Well, of course, there's a distinction between reforming renewable natural gas and renewing fossil natural gas. I guess that's in the
well, no, because essentially, if you take renewable natural gas and you burn it in a power plant, you're starting from the same point. Renewable natural gas. Now, granted, the renewable natural gas is way cleaner. It's like zero emission relative to natural gas from the ground, right?
Peter, it's actually negative. It has a negative carbon.
Okay, well, but in any case, okay,
It's
fine.
negative
That's
carbon,
fine.
but it produces criteria pollutants.
That's fine, but here's my point. Point is that its starting point is the same. If you take the renewable hydrogen and you convert it through methane reforming to hydrogen, or you take the renewable methane and you burn it in a power plant, you're starting from the same net negative point.
Okay.
So my point there is, wouldn't you be better off just burning it in a power plant? Now, I do understand about the criteria pollutants, the NOx and other things, but from a net CO2 emission standpoint, wouldn't you be better off just burning it? Because
well, and let me just contribute to the discussion here. This, like so many other things, is let 1,000 flowers bloom, I think, is what's going to happen. The great advantage in California and Oregon that have the LCFS is you have some very smart people doing the very calculations you're talking about. So at least we know what the carbon intensity is and we know whether we're shooting ourselves in the foot or not. And I do have faith that they're calculating this correctly. And sure, it all depends on assumptions, and sure, it depends on the details of where exactly the fuel comes from and exactly what the equipment is. But, you know, to a pretty considerable degree, the LCFS, I think, has done everybody a world of good by forcing people to sit down on a well-to-wheels comparison and just make sure that we aren't doing something that makes things worse. Leslie, you're close to this. I don't know.
I mean, I think if we're talking about transportation, we really need to go to zero, you know, because I mean, my very first or second slide with that pie chart, transportation is for when we're talking about criteria pollutant emissions, we need to move away from combustion. And those are the things that are harming, aggravating people's health, burning your eyes, causing the smog. So taking natural gas and turning it into something zero emission is critical. So what Peter's talking about here is it better to take it in a combined cycle power plant and produce electricity and put it on the grid versus taking renewable natural gas and producing hydrogen? And I'm going to say they're both important. Yeah. because that what hydrogen can do in especially a heavy duty vehicle, that's been my focus, is take the emissions out of transportation. And so the other alternative for taking the emissions out of transportation is charging big batteries. And we know, and we're going to start to see that for a number of reasons, charging batteries for heavy duty solutions is not going to be the only way we're getting to zero in transportation. So that's why it's important to think about, I mean, I get it. I know the state is very much focused on the electrolysis pathway, because that is absolutely the cleanest, greenest pathway. Also, there's the concern with methane. I don't care if it's renewable or not. That's just, renewable just talks about carbon intensity and the source of point A to point B, but there's a leakage factor. And when methane leaks, it causes issues. So managing methane. So one of the things I had once learned about, and I thought that was really, it's basically a comparison of fueling a natural gas vehicle, a combustion vehicle, versus turning that renewable natural gas into hydrogen. There's more emissions than just putting it in a car and burning it. There's all of the fugitive emissions associated with distribution and getting it ultimately into the tank of that natural gas car and truck. If you can take that natural gas at its source, at the dairy where it's produced or nearby, you are getting the carbon out at the source. Now you've got a zero emission fuel that you don't have to worry about, whether you're turning that into electricity or not. But then again, there are challenges to charging batteries that are a lot more challenging than filling up cars with hydrogen. And believe me, I sit in meetings on a regular basis, and all the time we talk about filling up zero emission cars is always focused on charging batteries. The hydrogen solution is really, really simple. We just need to sort of dedicate some resources and some money to it.
Yeah, well, as Thomas knows, I'm the lead advisor for SAC-EV, so I am a little biased. But you know, I guess what I'm, and I think I said earlier, I want to emphasize this again, that for heavy duty transport and maybe even forklifts in warehouses and things like that, hydrogen is perfectly fine. It's a great alternative. It's just that for light duty vehicles, especially now, because there's so few refueling stations, it seems like BEV is the way to go.
Kind of a similar thing that I have a question that I'll want to ask all of you is that I think everywhere in the clean tech space, we've all seen projects that never really came to fruition. And there's always, there's the obstacles of trying to get, even electric vehicle chargers in that have always been a pain. And I'm curious for getting, you know, whether it's fuel cells or projects or demos going forward in the hydrogen space, what has been usually, I guess, a point that the project ends up not working out, that maybe someone could go and say, go like an entrepreneur and say like, hey, you know, I can try to solve that solution so that we can get more of these projects. And while, you know, you're not going to ever have a perfect project, what is a way that an entrepreneur could go in there and try to figure out what's a way, how to get more hydrogen projects and develop more hydrogen technology to increase adoption?
Well, let me expand this question, because this is what our group is always looking for. Where do you think the opportunities are for innovation? Because people like to found businesses to solve problems. Where's a good problem that innovators should be working on right now to accelerate things that you've been looking at in your worlds? And maybe let's start with Leslie on that.
One of my passions would, everything has carbon in it, obviously, but everything has hydrogen, you know, organic, there's tires, plastic, there's so much garbage out there that if we were able to, the garbage that can't be recycled, that isn't being recycled, that if we were able to create processes and systems that use pyrolysis, which is a standard one, where you could actually produce hydrogen, and it produces hydrogen and electricity, it can produce syngas, it produces a resource, turn this waste that's filling up landfills into an energy resource, and start producing fuels with it. It can be done in a controlled setting. You can control the emissions, but it's taking a resource that is readily available, that is stuck in a landfill somewhere. This is one of my passions. There's all kinds of people that are going to shoot darts at you and say why you shouldn't do it, but I do think things are coming around. People are coming around. There's a really great consortium, I think, born out of LA, that looks at conversion technologies all the time, and they just keep getting bigger and more exciting with the things that they're working on. Just nodding his head, you have to know about this. It's pretty exciting.
Oh yeah, well, in our prior discussion with Dan Mazzoni at ITS in Davis, there's this well-cited paper where the calculation was done that because of the capture of the emissions that you were talking about at the source at a dairy, a cow is actually worth more as a source of LCFS credits than its milk is worth. So maybe we'll have to get Peter to get into the dairy business there and make negative fuels for us. But let me go to Roxana. Innovation, where's a critical problem that you'd like to see solved that maybe there's an opportunity that somebody here can be real creative with?
You know, this kind of relates to the discussion earlier about even hydrogen infrastructure and supply. You know, I had tons of producers that come to me, you know, asking where to go and where to produce. I think, like, you know, creating that competition in the market space is really helpful. And I think financing is a huge piece. I know that there's a lot of entities out there that, you know, they're in the game of financing, but the thing is that is, you know, that has been basically what, you know, stops every show from happening. Essentially, it is the game stopper, you know, and it's like the showstopper. And, you know, it's always like, how do we pay for that incremental cost? And so, you know, we're trying to come up with strategies politically and sometimes with private entities to overcome those challenges. But really, you know, an entity coming in and saying, we want to do massive financing of, you know, thousands of vehicles and create the demand that's possible, everything else actually can check out. You know, there are those that can then justify, you know, the financing of these massive hydrogen production plants. It justifies movement for the distribution of the fuel. You know, even the stations could be easily financed because there is that massive demand. But, you know, most fleets are not going to, you know, spend that much money getting state fleets to move over in that direction. I've I have funny lobbying stories about that, even in the state of California, with the state of California not even moving their own fleet over. So, you know, it's just having creative financing tools to be able to take as much risk out of this transition as possible, because it is a risk, right? I mean, especially in commercial sectors, you know, every time a vehicle or some sort of equipment is down, you're losing money, and that matters. And so something that can be creative and sensitive to those options would be really helpful. I think another aspect is really the education and handholding that's necessary for a lot of these end users. I don't think we really have a workforce that's ready for all of these technologies, not just hydrogen or fuel cells, but really a lot of clean energy technologies. And, you know, the end user's experience is critical, because if they don't have a good experience, then you're not going to see the massive proliferation of these technologies. I mean, I can give you tons of examples, but really it's going to be these ecosystems that are going to be the most important, pouring a lot of money into a central location that can utilize those dollars for different types of equipment, different types of technologies. It doesn't even have to be fuel cells exclusively. It could be any, honestly, zero emission technology. I mean, they do complement each other highly.
Well, I think that's a great point. I mean, obviously in the solar area, one of the things that really accelerated deployment was financial systems that and customer friendly ways to get all the permitting done that's made such a difference there. And I keep coming back to those LCFS credits. I mean, that's the net metering of the fuel world.
LCFS is only for vehicles. It's only in California. Oregon does have one, but I mean, it really, it's limiting. And, you know, it would be great if we had a national LCFS program, or we were able to get additional states to adopt it. It's really hard legislatively to get it through. But certainly, and that's just one aspect of it, right? That doesn't touch, you know, any kind of incentives for power production that might go into hydrogen production or anything else that's stationary.
Okay, let's turn to Jennifer. Innovation, where do you see that creative minds could make a difference?
Well, you know, I'm coming from a certain perspective, from kind of the technical side of it. And I think something that's come up a few times in this conversation is the competition, right? And so I think it's getting better, but I think that we still could use some competition in the marketplace, and things like components and materials and, you know, the kind of technical side of things, because, you know, for a long time, there was really one nozzle manufacturer that, you know, everybody kind of was forced to use this one nozzle, and there were some problems with it that, you know, people would address or identify. And it's like, now we have a few different manufacturers, and so there's a little bit of a choice, and that's creating some competition, you know. And I think that looking at, for example, the US DOE's annual merit review, they do a lot of R&D, and they have a lot of projects, and kind of getting an idea of what's being looked at there in terms of, you know, anything from valves to, you know, component level stuff to system level stuff, you know, tubing, compressors, any kind of materials for storage or anything. I mean, they're funding all that kind of stuff. So looking in those areas for, I'm not good with the ideas, but that's what you guys do really well, right? Entrepreneurs. So
Just gotta know where the targets are.
Yeah, I agree with you, Jennifer. I actually was just speaking with a company that, you know, one company actually forced a supplier to be exclusive to them, and that completely shut out everybody. And so really market diversity is really key, which is why we're so encouraging of, you know, as many producers coming online as possible. And I will tell you, just even popularizing hydrogen is really helpful, because I think that's why we're seeing so much private dollars coming into
Mhm.
this industry. So, we enjoy the hype that we're getting, and then all of us on the ground are really trying to ensure that the hydrogen industry is able to walk through this door fully and successfully, so that we can have different kinds of problems, like, the solar and wind world, right? Like, where they have more sophisticated problems now. We would love to be in that space.
Exactly. Do you panelists have any comment on what's called High Deal Los Angeles, the Green Hydrogen Coalition down there, and where that's going?
Muted.
I didn't even know about it.
Okay.
Yeah, I mean, there's so many new things happening in hydrogen so quickly. My colleague Keith Malone, who does, he tracks all the kind of news, and he's inundated. It's just kind of overwhelming, and the MOUs and the partnerships and all the different organizations that are popping up. It's there's a lot happening in the hydrogen space right now, and it's great.
If you had time to go through his updates and newsletters, I bless you. he sends a lot of really great material out, and I wish I had more time.
Yeah,
and there's a way to sign up to get his newsletters, and I'll find that out and send it on.
Also, I think that what's been a little frustrating for me is that, we've been talking about green hydrogen in California sometimes, or a lot actually, and throughout the US, and everyone seems to have different definitions. Some people are pulling basically this electricity off the grid, and it's actually not fully renewable. And, actually the carbon intensity of hydrogen coming from renewable natural gas is a lot lower, tremendously lower than the carbon intensity of hydrogen coming from electrolysis, even from the California grid. And so, I'm really sensitive to this, because I don't want us to, I'm very sensitive to our industry being caught up in greenwashing, or later on dealing with the repercussions of this. Of course, I work a lot in advocacy, and so these things are really critical. I really am just kind of like, we do not create a number of colors for electricity. If that hydrogen is produced from renewable electricity or renewable gas or some feedstock that's renewable, it should simply be renewable hydrogen. It really does deserve that. And I think, the hydrogen industry sometimes is because it's an underdog, like, it's been cheapened in some respects. And so we really want to make sure that we elevate the terminology, renewable hydrogen, getting credit when it's certainly deserved.
Well, we're going to have to wrap up here at the end of our time. Really appreciate what the three of you have done. It's been a tremendous discussion. And it just reminds me that, you've talked about competition a number of times, and when we follow and we have one of these sessions with the battery people, they talk about, we're getting longer duration storage, we're getting more megawatt hours per kilogram packed into a battery, and we're not conceding any of the market to the hydrogen folks. It just means, both camps and many more camps are probably going to succeed here. There's a role for many things to happen. And out of that, we hope that the innovators will find a pathway, and the commercial markets will sort this out. But it's been a tremendous discussion. I thank you all for giving your thoughts and your participation. Thanks everybody who has tuned in here. This will be available. It's recorded. It'll be on our YouTube channel. We'll summarize it and get that out. So if there are other people that you think would benefit from hearing this, please have them tune in to those sources. And we'll have future perspectives and meetups coming up. I think is this the last meetup of the year? Thomas, take it from here.
All right. We do have one more meetup coming up, and we will announce it hopefully soon. As Gary mentioned, all these, I edited them down a little bit and we put them on our YouTube along with the live ones. You can check out past ones that were really exciting and very interesting around grid formation and community projects. Additionally, I want to thank our overall program sponsors, Momentum, Moss Adams, GT Law, Penn Motion, Hacker Lab, where I'm at right now, and Reverent, and our community of partners. Thank you all for attending. Sorry if we didn't get to the last questions on it, but I always make the promise that we're out by 7. And we're doing it again. Success.
Yeah, that's
Thank you
great.
all.
And November 18th, our next spotlight pitch session. You may have mentioned that, Thomas, at the
Yep,
beginning.
November 18th. Save the date. It'll come out. Spotlight pitch. We'll have a couple companies pitch to a panel of experts and give them feedbacks.
Yeah.
Also, Global Entrepreneurship Week is starting in just over a week. And on the 10th, we are talking about how to move from engineering to entrepreneurship with the College of Engineering and Computer Science. So I'll throw some more links in there, and you can reach out to all the presenters and sign up for their newsletters, follow them on LinkedIn. I know that's one of the best things about this is just going and following people on LinkedIn so you can see all the cool stuff that they're doing. Follow CleanStart and, support us, and let's change the world.
Absolutely.
You're here.
So, very good. Thank you all. Thank you all for participating, and thank you all for
Thank
being
you.
here. It was really
very much.
tremendous. Thank you so much.
Take care.
Thank you.